Welcome to our video lesson on one of the most essential appliances in our homes, refrigerator. Have you ever paused to think about the amazing technology that keeps our food fresh and our drinks perfectly chilled? Today, we are going to dive deep into the inner workings of this fascinating machine. Think about it. Every time you open the refrigerator door, you are tapping into a marvel of modern engineering. But how exactly does it work? How does it manage to maintain a cool environment inside while the temperature outside might be sweltering hot? Let's start by understanding the basic components that make this possible. At the heart of every refrigerator is a system designed to move heat from the inside to the outside. This process involves several key components: the compressor, the condenser coils, the evaporator coils, and a special fluid called refrigerant. Let's compare the refrigerator to a heat pump. Both systems use similar components and principles to transfer heat. Here, you can see the compressor, condenser coils, expansion valve, and evaporator coils in both devices. The refrigerant absorbs heat from one area and releases it in another. In winter, it can extract heat from the outside air and release it inside, while in summer, it can do the opposite.
Based on what SYAZWANA has explained about the schematic diagram of heat pump and refrigerator, my turn is I will explain about the component of heat pump and refrigerator that cause heat transfer from cold to hot reservoir. First, we have evaporation. The working fluid enters the evaporator as a low pressure. The cold liquid will absorb the heat, transforming it into a low pressure gas. As the working fluid absorbs heat from the cold reservoir and the surrounding areas will cool down. Second, we have compression. It compresses the low pressure gas from the evaporator, raising its temperature and pressure. This compression process significantly increases the temperature and pressure of the working fluid or refrigerant, preparing it to release heat in the condenser. Third, we have condenser or condensation. The condenser located in the hot reservoir releases the heat into the surroundings as the high temperature gas from the compressor condenses into high pressure liquid. And lastly, we have expansion, that caused by the expansion device. The expansion device reduces the pressure of the high pressure working liquid, causing a drop temperature before standing back into the evaporator to absorb more heat. The refrigerant keeps going through this stage, whether it's continuously absorbing heat from the inside and releasing it into the room in a refrigerator, or heating a space by absorbing heat from the outside and releasing it inside, or cooling a space by reversing the process in a heat pump. This system follows the laws of thermodynamics, which explains that the energy absorbed in the evaporator is equal to energy released in the condensers. The law of thermodynamics that the heat pump follow is the first law of thermodynamics, which is energy is conserved in the system, meaning the energy absorbed in the evaporator and the work done by the compressor is equal to the energy released in the condenser. Second law of thermodynamics also followed by in this heat pump, which is the heat naturally flows from hot to cold regions, but with external work, which is by the compressor. Heat can be forced to flow from cold to hot regions. So this is also that show that while heat naturally flows from hot to cold, external work like that done by the compressor can force heat from cold to hot. In short, the parts of heat pump and refrigerator works together to move heat from a cold area to warm area. This process is driven by the compressor's work and follows by the principle of thermodynamics to achieve the desired heat or cooling effect.
Now, I will take the responsibility to explain about COP of refrigerator and heat pump. Do you know what is COP? COP is a coefficient of performance, which is a ratio of useful heating or cooling provided to work energy required. For higher COP equal to higher efficiency, lower energy, thus a lower operating cost. By the way, you can also use thermal efficiency, but today I will explain how to use COP. So, for more understanding, I will attach a diagram. So, I will explain the diagram first. So, if you see the diagram, it has two Q, which is Q1 and Q2. The Q represented as heat. I think everyone knows what the Q meaning. So, Q1 is heat in the refrigerator and have a low temperature. And Q2 is high temperature, where when the heat out from the refrigerator, which is the heat is in the surrounding. Okay, to let everyone know, this situation when the refrigerator transfer from cold to hot, so we need to input some work to maintain the system. Before we see how to calculate coefficient, let me explain a short function of or term of heat pump and refrigerator. Heat pump is a device that transfers heat from a colder area to a hotter area by using mechanical energy, same as refrigerator. How much heat is rejected at higher temperature is an important quantity for a heat pump. Next is a refrigerator function, which is the function is to remove heat from a space that lower temperature than surrounding. Without wasting any time, let's see how to calculate a coefficient of performance for heat pump and refrigerator.
Okay, we will start our explanation about coefficient of performance for heat pump. So, if you can see this picture, the Q1, which is in the refrigerator, have a low temperature, like I said before, and the W is the work done on the system. And also we have Q2, which is at the room and with a high temperature. According to my research, the coefficient of performance described as desired output over required input. So, for this situation, our desired output is Q2. So, we can put in the formula, which is COP H equal to Q2 over W input. And to let you know, W input also mean of Q2 minus Q1, which is Q at high temperature minus Q at low temperature. Okay, let's proceed to the coefficient of performance in refrigerator. So this situation is same as a heat pump, which is the COP is the same, but the desired output, the difference is at desired output. So if you can see this, before this desired output at Q2, right? But this situation, our desired output is in the refrigerator, which is Q1. So we can substitute the desired output as Q1 and required input also same, which is W input. So coefficient of performance in refrigerator we can say as Q1 over W input. So as you can see in the slide, we have three equations, which is 2 and 3 that are already explained before, and the first equation, which is Q1 plus work input equal to Q2. So if we take the first equation and divide by W input, we can get the Q1 over W input plus W input over W input equal to Q2 over W input. If you can see this formula, it related to the equation number 2 and number 3, which is Q1 over W input same as coefficient for refrigerator, and Q2 over W input equal to coefficient for heat pump. So we substitute them. So we got a new equation, which is coefficient of refrigerator plus 1 equal to coefficient of heat pump. So the conclusion, the coefficient for heat pump will be higher than coefficient for refrigerator because the heat rejected to the hot sink is greater than the heat absorbed from the cold source.
To answer the question, we need to know what formula that we need to use and identify what are the information given. The coefficient of performance, COP, of a refrigerator is defined as the ratio of heat removed from the refrigerator to the work input required to remove that heat. The question stated that the desired refrigerator temperature, which is TC, is 4 degrees Celsius, and for the room temperature is 25 degrees Celsius. Then we need to convert from Celsius to Kelvin. So what formula that we need to use? We need to use the formula for COP refrigerator, which is E equal to TC over TH minus TC. Then we substitute the value from the above information given into the formula. After calculating all the calculation, we will get the final answer.
Now, we are going to look at how a refrigerator works. A refrigerator uses a refrigeration cycle to keep things cool. It has a compressor that circulates a refrigerant through condenser coils where heat is released into the kitchen, and evaporator coils inside the fridge where the refrigerant absorbs heat, cooling the interior. Now, to understand more about how a refrigerator works, here's an example. One day, Ahmad opened the refrigerator door to take some fruit, and then he left the kitchen. After a while, he began to doubt whether he had properly closed the door. Do you ever wonder what would happen if the refrigerator door were left open? When the door is left open, the cold air from inside the refrigerator escapes into the kitchen. This causes the temperature inside the fridge to rise because the appliance can't maintain the cool environment needed to preserve your food. With the door open, the compressor starts running continuously because it can't reach the set temperature with the door open. This will result in several issues. First, this can cause the reduced lifespan of stored goods. These random temperature fluctuations potentially accelerate the decomposition phenomenon in the stored goods. Perishable items such as meat, dairy products, and frozen meals are particularly vulnerable to spoilage as they thaw. This can result in food wastage and the risk of consuming spoiled or unsafe food. Second, since leaving the fridge door will cause the refrigerator to consume more energy to maintain the inside temperature, the excess energy it is consuming is simply waste that could have been avoided. This further harms the environment due to increased energy consumption. This increased energy consumption not only impacts the efficiency of the appliance, but also leads to higher electricity bills. Next, leaving the refrigerator door open also impacts the lifespan of the refrigerator. Since the refrigerator needs to maintain the temperature inside it, it needs to put extra strain on the freezer's components, including the compressor, evaporator, and condenser. This will lead to increased wear and tear on the compressor. This also will potentially detrimental to the overall lifespan of the refrigerator, leading to frequent breakdowns. Another problem is increased humidity. When warm, moist air from the kitchen enters the refrigerator. It causes condensation and frost to build up. This can lead to water leakage and further inefficiencies in cooling. As the ice melts, it turns into water and can start leaking from the freezer compartment. This can lead to water damage not only within the freezer, but also in the surrounding areas of the refrigerator. Water leakage can damage the flooring, cabinets, and nearby electronic appliances, causing costly repairs and inconvenience. So, Leaving the door open is clearly not good for your refrigerator. But what about cooling your kitchen? Let's explore that idea. Refrigerator works by removing heat from the inside of the appliance and releasing it outside through the condenser coils located at the back or bottom of the refrigerator. When you leave the refrigerator door open, the appliance has to work harder to maintain its internal temperature, which can cause it to generate more heat. This extra heat released by the refrigerator can contribute to an increase in the overall temperature of the room, offsetting any cooling effect you might have been hoping for. According to the principles of thermodynamics, the total energy in a closed system must be conserved. This is the key factor. The heat isn't destroyed or stored, but moved. To make one thing colder, you must make something else warmer. The heat has to go somewhere. When you leave the refrigerator door open, the heat it removes from the air near the door is simply pushed back into the room on the other side of the refrigerator and then flows back into the area being cooled outside the open door. This means that while the distribution of heat in the room changes, the room as a whole will not get any cooler. In fact, if you leave the door open for more than a very brief moment, the room will actually get warmer overall. Another implication of the laws of thermodynamics is that work is never 100% efficient, so there will always be some amount of energy that is used but does not contribute to the work's results. Normally, this energy escapes the systems as heat. In this case, the energy being used to do the work is electricity, which is transformed into mechanical energy in the motor that drives the pump that keeps the refrigerant moving through the cycle that moves the heat. A small amount of that electrical energy becomes heat due to friction in the motor, and that heat makes its way into the system's environment. In simple terms, by leaving the refrigerator door open, you are not just failing to cool the kitchen, you are actively making it warmer. So, next time you doubt whether you close the refrigerator door, go and check it. Keeping it closed will save your food, save energy, and keep your kitchen cooler.
Thank you for listening to our video lesson. Bye bye.